Okay, I want to do some Snell's law problems. I'll start with number 3 because if you know how to do that one, number 2 and 1 are relatively simple. Keep in mind, doesn't say it here, water has an index of refraction of 1.33. Kind of need that for this problem. But let me go on to problem 3. So rays of the sun make a 21-degree angle to the vertical beneath the water. What angle above the horizontal is the sun? So basically I'm looking for the direction to the sun. You're sitting on the water and wanting to know the angle at which you lift your eyes above the horizon to see the sun. Yes, that is what we're talking about. Let me do it on a scratch piece of paper here. So, 3, we are considering the water. This is the water here. And we have, first thing I want to do, since this is the interface where the light strikes and gets refracted, you want to be careful to keep in mind what the normal is. This is the normal. Now, a sun ray comes in. Okay, so the sun ray comes in, hits it here. And by the way, this is theta incident. This is the incident angle between the direction of the ray and the normal. Now when it goes to a slower medium, this is water, so n is equal to 1.33, n of air is equal to 1.0. When it hits a slower medium, like water is, it bends toward the normal. Okay, so it refracts, you could say downward in this case, so theta r. There's the theta refracted. And the refracted angle is given as 21 degrees. So we know what that is. That's theta r. All right, so basically, you know, our formula is n1 sine of theta 1 is equal to n2 sine of theta 2, or n incident sine of theta incident is equal to n refracted sine of theta refracted. Functionally, this may be a better way to think about the problem. Now what we're really doing is looking for the incident angle. We want theta I. So let's solve for that. Sine of theta I incident is equal to n refracted over n incident sine of theta refracted. There it is. So the angle, theta I, is equal to inverse sine of this whole thing. Now what do we know about nr? We know that it's 1.33. It's the refracted index, and ni is just 1, the air. Sine of 21 degrees. So that is the incident angle. And that'll give us, let me throw that in a calculator, we should get 28.5 degrees. Now, is that the answer? No, that is simply this angle. We are looking for this angle, theta horizontal. Therefore, theta horizontal is equal to 90 minus 28.5, which is where I get the 61.5 degrees as the answer. That's the direction that you have to look to see the sun.